Morning, everybody. How's this camera feed? Is this okay? Is it blurry?
Oh, thanks.
Cookies sound good. All right. Brian, you're not muted. It's okay. Hey, a few things for us. Don't forget. Okay, so here's the plan. Thursday is our midterm. Okay. How it's going to work Thursday again is Thursday is all multiple choice. 25 multiple choice questions. All right. It's about 23 single answer, 20, and then 2 or 3 double response. Okay. Just like you're going to have on a regular AP exam. Most of it is going to be over fluids. That's going to be the largest chunk. Okay, that's a unit that we've completely covered. It's the newest unit that we haven't tested yet. So the largest chunk is going to be over fluids, maybe 45% or so. Okay, haven't made it yet, so I don't really know. I'm just giving you an idea of what it's going to be like. Right. The rest of it is going to be the second heaviest topic would be thermodynamics. Right. The third heaviest topic would be electrostatics. Right. If you guys could do me a favor, go into Schoology real quick. And on Schoology, there is a folder titled Midterms. And let me get there as well. Under midterms, there is topic reviews, okay? This is information from a review book that is published, right? That I basically have a PDF of that I post for you guys that you can review. And so you'll see fluids review, thermodynamics review, and electrostatics, okay? What it does is it gives a quick topic overview of all the different ideas within each unit. It then provides also practice questions. I don't believe the practice questions are as good as just the content for the review, okay? So it's just another place you guys can go and look at, hey, here's an overarching review of thermodynamics. Here's an overarching view of fluids or of electrostatics, okay? The things that we have talked about. Obviously, thermodynamics, we haven't covered the entire unit, so if there's stuff in there that we just haven't talked about, that's okay because we just haven't talked about it yet, right? And the test is going to reflect the questions that we've discussed so far, not things that we haven't discussed, okay? Also on AP Classroom, all the progress checks are posted, right? As well as I posted the scoring guides for the free response questions, okay? So that's a great resource. Whether it's later today, whether it's tomorrow on your day off, right, to go through any of those questions, right? I, again, will be online from 7:45 to 8:35, right? I'll be at home, but I'll be online. That if you guys would like to come in and have a review period or have questions that you'd like to ask me, that's time that I'll be available for you guys as well. It's not a requirement, but it's just a time where you guys can hook up with me and go through some things, okay? Questions with that? So that's all stuff for review. I asked you guys yesterday to finish the thermodynamic concept questions, yes? I think, yeah, 1, 2, 3, and 4, right? And I apologize again. I meant to do that last week for you guys, but so let's spend the first part of today going through those. All right, so if you guys have your concept questions for thermodynamics, we'll go through those. And then the second half of the day, whatever we have time left, is just going to be your guys' time to either ask questions or work through maybe some of the AP Classroom review or just look at review material from those PDFs that are posted, kind of whatever you feel is best for you. I'll also do a quick just overview of things we talked about in electrostatics, things we talked about in fluids, things we talked about in thermodynamics so far. Okay?
Do you have a copy of the concept question? I've been doing it by just online.
That's okay. I have one copy.
I can just take pictures.
I don't know if I have additional copies. Because I think I handed them all out.
Well, I can print it out home.
Okay. Did you get a copy originally? No.
I can just take pictures.
Do you have the PDF?
Yeah.
You can find the PDF.
Is PDF in school?
Yeah. It should be in the unit. I mean, I know I had some printed off, but I thought I had given them out previously, but was there, it might have been the day, because you were absent a day or two last week, right?
Yeah.
Or 2 weeks ago?
Yeah.
Or you still joined, but you just weren't here. Let me get attendance real quick. Did you ever find that live stream I sent you? Yeah. I mean, I'm live streaming right now on the tube. It worked out because last week, for some reason, this setup wasn't working because the camera is subpar, I would say. And for AP Physics 1s, the kids were like, I can't see anything that you're writing. So I was like, all right, well, I'm on YouTube. And everyone jumped over on YouTube. So it just kind of worked out. But then for the AP Physics, I don't know if I told you guys this, for AP Physics 2, for this class, I did it last Tuesday I did it. Last Monday, I live streamed it on YouTube. And there was someone not in the class that joined the live stream. And they were typing questions in the comments, and I didn't even realize it until after the class was done. He was like, "What is the value of R?" Yeah, just some random student. I have no idea. I guess I don't know if it was a student. It was just some random person that was on there. So. All right.
Can I keep this?
Yeah, that's fine. Okay, I need to pull up the concept questions here. If it is, for people that are here, if it is blurry for you, I am live streaming on YouTube. Just make sure you give a subscribe and a like. All right, we'll get this class viral. Now, my computers are running probably substantially slower with everything I'm trying to do though, all at once. All right.
Yeah, I was stuck with number 4.
Thermodynamics number 4?
Yeah.
Okay, well, let's just go through, and we don't necessarily have to solve all of them and calculate all of them, but let's just go through we'll just kind of go through them step by step and see how things go. Sorry, I'm a little distracted with everything I have going on right now. Okay, So question number one, thermodynamics question number one. It says find the temperature at point C in terms of the temperature at point B, right? So again, with this temperature, we're going to use PV equals nRT. Okay, the relationship between pressure, temperature, and volume, right? If we looked at TB, right, the temperature at B would be what? Pi Vi over nR, right? That would be my temperature at B. Does everybody agree with that? I'm simply taking what is recorded on there, right? In terms of the temperature at C then, how would I record and write down what the temperature at C is? Look at our graph. What would I write down?
The PI 2VI.
Yeah, Pi 2Vi over nR, yes? Okay, so what the question asks is, what is the temperature at C in terms of the temperature at B, right? So I could say then TC equals what?
2.
Absolutely, 2TB, right? It's twice the temperature, okay? It's twice the temperature. Cool with that? Find the pressure at point D in terms of PI. I'm just going to draw the graph up here just because so I can see, because as I'm going down, it's what? A's here, B's here, C's here, and then D's here, correct? And it goes this way. This is the cycle that it goes in. And this is an isotherm. Right? What does isotherm mean? That means TA equals TD. Right? Isothermal temperature stays the same. Isolate the temperature, right? Keep the temperature the same. All right. So what it's asking then for in this, I'm just gonna write this. This is 3pi. This is pi. This is vi, and this is 2vi. Okay. Find the pressure at D in terms of pi. What are we thinking? Everyone left my Google Meet. Okay. Find the pressure at D. How are we going to work through that?
P is nR2 over V.
P, okay, so P equals nRT over V, yeah?
And V is 2VI.
Okay, so, and this is just pressure, and then pressure at D is nRT over, you said 2VI, right? Okay. And what's PI? So in terms of this, the thing that we know, because this is an isotherm, yes? let's do this. The pressure at A is PA would be nRT over 3 VI. Do we agree with that? Or am I doing that wrong?
Oh, it's
Let's just write it this way. I'm going to write it this way. At A, it's 3 pi VI equals nRT. Yeah? You cool with that?
yeah.
At D, it is P, which that's what we're looking for, right? 2 VI equals nRT. And what do we know? We know that these T's are equal, yes? Okay, so if these T's are equal, this entire right side of my equation must be equal, right? So we can get rid of this and say that 3 pi VI equals P 2 VI. Yeah?
Yeah, I don't really understand this one.
VI's go away. And we get P is equal to 3/2 PI. These markers suck. Is this better? Okay, so Artemi, if we take a look at this, right? We're trying to find the pressure here.
Yeah.
Yes? That pressure obviously is greater than PI, but it's less than 3 PI. Okay? What we know is that my ideal gas law, right, is PV equals nRT. Okay? And so just based on what the graph is showing me, at point A, it's 3 PI
Yeah.
VI
Yeah, I get
equals nRT, right?
Yeah, but
And then this is TA. Cool with that? And then here at D, it's whatever the pressure is. And that's kind of what we're trying to solve for, pressure at D. Yes? And that's kind of what we end up solving for.
yeah, that's why I don't understand it. Like we don't know the pressure, but you said that 3 VI is equal to.
Yeah, so this is 2 VI. You good with that?
Yeah.
Twice the volume. And RT. Okay? This is TD. And what we said is because this is on an isotherm,
Yeah, same time.
the temperature at A and D are the same, right? So look at this side of the equation and this side of the equation. These are equal, right? N is going to be the same. R is going to be the same. And then T is obviously the same, okay? So what I can do then, if I know this and this are equal, right? Then doesn't that make this and this equal as well?
It does.
Right?
Yeah.
So what I did then is I said, okay, 3 pi VI equals PD times 2 VI. And then I'm just solving for this.
Okay.
Go with that?
Yeah, in the next step. Okay.
In the next step, then I'm just solving for PD. So I divide each side by 2 VI. 2 VI. The VI's here go away, right? And I'm left with 3/2
Okay.
PI,
Makes sense.
right? Which, why does 3/2 here make sense?
Because it should be the same as.
Based on my graph, like this is PI, yes? So it better be bigger than 1, but it better be less than 3, yes? So 1.5 makes sense. And it also makes sense because it's closer to 1 than it is to 3. Yes? It's a half the pressure bigger here, or it's 1.5 less here. And that makes sense just on what the graph actually looks like. Cool with that?
Yes.
All right, question C. Find the work done by the gas in moving from state A, B to C, right? So from A to B, how much work is done? If you guys don't, have your equation sheet out so you can look at, like, what's the equation sheet, right, that I would be referencing, right? On Thursday, I know people aren't going to be here, but I would highly suggest, right, just what you should have out is your reference sheet, okay? You're taking a test at home, right? Guys, there's retakes, or there's not retakes, but there's corrections, right? There's a curve. Like, the point of this is to see what you can do, okay? Obviously, there's tons of opportunity for you to not be honest in how you do, right? But my expectation is that we can get past that, right? To understand that this is not about, like, you. It's more about seeing what you need to know, right? And seeing what you need to continue to get better at, instead of just like, oh, I need to get an A on this test. Guess your grade's going to be fine. Okay, let me just tell you this: your grade's going to be fine. Right? If I told you that you're going to get an A in the class, like, you wouldn't cheat on the test. You would do it to see what you know and what you need to continue to work on. Tomorrow, for when you're at home, right, you should have your Chromebook open, right, a scratch sheet of paper to do work on, but then have your reference sheet out, right, because that's the one thing you're going to have on your test as well. So what equation? Let's just do this. What equation am I going to use to solve for work?
Minus V delta V.
Yeah, work equals negative pressure delta V. Yes?
Yeah, and
A to B, how much work is done?
0,
Why?
because there's no change.
Yep. Volume doesn't change. There's no work done when the volume doesn't change. Okay? A to B, it happens in part D. I always get ahead of myself on this question. I remember. Okay, B to C then.
That's negative.
The volume is increasing, yes? So is the gas then that is work done by the gas. Okay? So that's work is negative, yes? How much work is done in this case?
1.
It's negative PI 2 VI minus VI, yes? So my work then would be negative PI times VI, yes? Negative PI, VI. That's how much work is done. Everybody cool with that? And then what's it say? Moving from, say, A to B, B to C in terms of PIV. So that's the total work done. Yes? Okay. Moving from state A to C, what happened to the temperature? From A to C, the temperature stays the same?
Oh, no.
From A to C.
Yeah, the pressure decreased. So. Oh, wait.
What happened to the temperature?
Yeah,
TA, TC. This is just, I'm throwing it, which one's higher?
Oh, TA.
Yes? 3 times 1 is 3, right? 2 times 1 is 2. So it cooled down. Yes?
Yep.
I mean, because PI could be greater than VI.
What's that?
PI and VI are equal, so you can't really compare.
Right, but if this is in terms of V, if this is in terms of this, right? TA would be 3 PI VI, and this would be PI 2 VI. Yeah.
I don't know.
It's early. It's okay. It's early. I know what you're saying though, right? But because they're in reference to that, like, we can still compare. Okay. Everybody cool with that? All right. So then, D, in which process is heat taken from the gas? Explain. Right. So that now is looking at the equation. change in internal energy equals W plus Q. Yes? Okay, and which process was heat taken from the gas? And I think, guys, for all of these, it's still worth just going through each one, right? A to B, what happens? The temperature goes down, yes? There was no work done, so how does the temperature go down?
Lower pressure.
Right? How does the pressure drop? Think about this. Think about this, okay? What was this? For A to B, this was 0, yes? What is this? Change in internal energy measures the temperature. So what's this? This goes down. So what has to be true about this? Or this is a, this is a negative, yes?
Yeah,
The temperature goes down. So what has to be true about Q?
It's also negative.
It's also negative. So A to B, heat is lost to environment. Okay? My everyday example. Take a balloon, right? Take a balloon and put it in an ice bath. Yes? Well, no, we can't do a balloon because we have to keep a constant volume. Yes? Take a soda can. You guys did this in chemistry, yes? Where you took the soda can, you heated it up, and you turned it upside down, and it crushed itself. No?
No.
All right, I'll send out a video of that. Take a soda can, right? Put it in an ice bath. What happens? The pressure goes down. The volume stays the same. The pressure goes down, right? And that's why we get that. Cool with that? Why does the pressure go down? Because, we have our soda can here. We have our ice bath. This ice bath is cooler, so heat transfers out of the soda can. Yes? In that case, then, we're losing heat to the environment. Everybody cool with that? B to C, we said what? For B to C, we said this is a positive, right? The temperature goes up from B to C. We said the work is, no, we said the work was negative, yes?
Wait, what's it? B to C?
Yeah, B to C, here to here. We said the work was negative, right? So what has to be true about Q? It has to be a positive. Yes? And this has to be greater than this. Yes? So we're not losing heat to the environment. Heat is being, now we're going from an ice bath and we're putting it in a boiling water bath. Yes? Everybody cool with that? What about C to D? C to D. Change in internal energy, that's a positive, yes? Temperature goes up. Same volume, higher pressure, temperature must have gone up. What about the work? It's 0. Vertical line, work is 0. There's no change in volume, so there's no work. So what has to be true about my Q? It's got to be a positive. I had to gain heat in that circumstance. Cool with that? Okay, what about D to A? Change in internal energy is? 0. Good. Equals. What's my work in this case? Oh, it's a change in pressure, right? It's a change in pressure, but who cares? Look, if this direction is negative work, yes? The other direction is positive.
Okay.
So that's positive, yes? So my work is positive, plus what has to be then true about my Q?
It's negative.
It's got to be a negative, yes?
And
And they have to be equal. Yes? Cool with that? So what are the two circumstances where heat is taken from the gas? Right? Heat is taken from the gas during A to B, as well as during D to A. Okay? And it's using this idea of changing internal energy. Remember, internal energy is measuring the kinetic energy of the particles. Kinetic energy of the particles is measured by the temperature. Okay? The work done, right? Work is negative pressure delta V. Q, then we can determine Q if we can know the other two. Are we okay with that? All right. Let's turn the page. Brian, do you still have a question? You typed a question. Sorry, I'm not focusing. I'm like on a different tab on this for my live stream. Do you still have a question? Or did I answer it? How does temperature go up on B to C if the volume increases at the same pressure? B to C. Remember, temperature equals P times V. Right? Okay. You said never mind. Seems like we're good. Okay. Thermodynamics question number 2. The correct answer is C and D.
Wait, why A?
Which of the following are the same regardless of the pathway? Work done on the gas is the area under the curve. Do they all have the same area under the curve?
No.
No. Which one would have the most work done?
C.
C would have the most work done. Okay?
Okay. The logic I used is that all of them started at the same point.
Yep. And that's true, right? And so that tells me that their initial temperature and their final temperature are the same.
Yeah, I chose,
Right?
I
But-
chose A and D.
Yeah. The process of which they got there is different, right? One has more work done, so that must have less heat added, right? Whereas one has more heat added, so it must have had less work done. Cool with that?
Yes.
Change in temperature of the gas, the average kinetic energy of the gas molecules. So C and D for that one. Okay. Thermodynamics question number 3. How much work is done on the gas during this process? My hope is we can find the area under that curve. Yes, we have a rectangle, we have a triangle, and we can find the area under that. The biggest thing that people are going to make a mistake with this one, guys, is they need to find this entire area all the way down to the x-axis, okay? Not just here, right? And then also they'll make the mistake that they'll find this triangle here, but they won't find this area down there. So you have to make sure you're finding the entire area, okay? You kind of have 2 rectangles and a triangle. This rectangle, that rectangle, and then that one. Or, a rectangle, a square, and a triangle, all right? But you got to find the total of all of that, okay? Everybody cool with that? All right. Lastly, then, I have no idea. I'm not going to worry about it. So here's the reason I'm not going to worry about it, because their volume is in cubic centimeters and their pressure is in kilopascals. So you'd have to do metric conversions. So I don't even care, right? The AP exam's not going to have you do that. They're going to give everything in the SI units that you need. They're not going to have you do metric conversions. Fair enough. So, but the process is the same, right? Okay. Question number 4, determine how many moles are in the cylinder. Again, I'm not going to worry about this. The big thing of how you would do that is moles is PV equals nRT. Okay? So writing that down for question number 4A, PV equals nRT. You're solving for moles, so what are you solving for? You're solving for N. Okay? Again, they give us temperature in Kelvin, which is great. They give us pressures in kilopascals, so we'd have to convert that to 20,000 pascals. They give us our meters cubed, so really everything here is good. You just have to solve for N. Everybody okay with that? Do we need to walk through that, or are we okay? I can't see when people comment. Calculate the temperature of the gas at the following states, B and C. Again, with that, we would just do temperature equals PV over NR. Yes? R is a constant on your reference sheet. Okay? I know there's another way to reference the PV equals nRT on our reference sheet. We're not going to deal with that one right now just because we haven't addressed it. Okay? C, determine the net work done on the gas during the cycle. So I like this. Let's just set this up. When it says the net work, so our graph looks like this. We have A, C, and then B. A, B, C, and it goes in this direction. Okay? The net work, right? So think about this. During one complete cycle, we have this. There is work done here. Yes? There's work done there from A to B. And there is also work done from B to C. Yes? And then from C to A, is there any work done? No. So from A to B, that is negative work. Yes? My volume expands. Work done by the gas. It's losing energy. Okay? B to C, because my volume is getting smaller, that's positive work. Right? Which one is bigger?
AB. Oh, wait, no. BC.
BC.
Yeah.
Yes?
Is greater.
BC is greater, has a larger area. Yes? So the net work then, like this,
It's how much larger?
is my net work. Yes?
So your difference between
The difference of the works. Okay? Add up the works. Cool with that?
That's the answer to C.
Yep.
Can you explain it again?
A. Have you taken chemistry?
No.
Oh, well, yeah, okay. This is my number of moles. So it's just N equals what? PV over RT?
Yeah.
Okay. R is a constant on our reference sheet that we can find. Sorry, I assume people have taken chemistry, and if you haven't, that's what moles is like one mole is what? Does anybody remember Avogadro's number? What was it like? It's big. What is it?
It's like something like 2.
Yeah, it's like 6. Is it like 6 point something? It's like 6.2 something.
6.02
6.02 times 10 to the 23rd. So that's how many particles. Is it particles?
Yeah.
It's how many particles like one mole has. Like a mole is just a quantity of things. Like if I have a dozen people, right? That's 12 people, right? Well, a mole is 6.02 times 10 to the 23rd. So if I have 1 mole, that's how many particles I have. If I have 2 moles, I have that times 2. If I have 3 moles, I have that times 3. Okay.
It measures number of
It just measures the number of particles that you have. Like, remember when we did that virtual simulation and like you pumped the, like think about every time I pumped it, I add a mole. It's not really, but I add a mole of particles. Cool with that? Okay, lastly, explain whether heat was added to the gas or removed from the gas during the cycle. Justify your answer. I like this purple, shows up really well. So the very last question, very last part, 4D, we have to think about you're starting at A, yes? And you go from A to B to C back to A. That's our cycle, yes? So the change in energy of the cycle equals the net work plus the net heat added or lost, yes? What is my change in energy of the cycle? Right, one cycle
Okay, so William stayed the
is
same.
A to B to C back to A. That's one cycle, yes?
Oh, yes.
What's this? Why?
Because temperature's the same at A.
Yeah.
Yeah, PV at A still equals PV at A, yes? So this is 0. Are you cool with that? What about my net work done? We already said A to B is negative, B to C is positive. We said B to C has more than A to B, so work is
Positive.
So what's Q? There you go. So heat is lost in the cycle, right? Going throughout the cycle, in total, heat is lost. Why do I know heat is lost? Because I have more work done on it, right, to add kinetic energy, but I have to lose kinetic energy through this heat that is lost. Because the temperature at A is always the temperature at A. Cool with that? Okay. Questions?
Yeah, that's interesting. You don't even have to calculate.
Yeah, like with this idea, and if we understand what this is telling us,
and you
right?
know that work is positive.
We know the work is positive. Like I can understand this. Okay, these are super simple equations if we can understand what they're telling us, right? And I know we haven't done a ton of like real world examples of like what they are. I just apologize because for me being out, we just haven't had that opportunity, right? But yeah, it's super simple in terms of math. It's just making sure we can apply it to the situation. Okay. Deep breath. Is that just me? I will be online tomorrow, 7:46 to 8:35, right? If you have questions, okay, and you want to go through things, remember AP Classroom. So on Thursday, multiple choice questions. On Friday, free response questions. I'll just tell you, one's going to be thermodynamics, one's going to be fluids, okay? There won't be an electrostatic one. It's just going to be thermodynamics and fluids on Friday, okay? Same idea on Friday, right? You should have your reference sheet. You should have a calculator, okay? You're going to email me your responses, okay? So the test is going to become available at 7:40 tomorrow, right? And on Friday. The test is going to be posted on Schoology at 7:40, right? You'll have until 8:40 to submit it, right? On Thursday, it's just multiple choice questions, so you just got to submit it on Schoology, all right? On Friday, the free response questions, you're just going to email them to me. Just do them on a piece of paper, take a picture, and email them to me. Okay, I think that's going to be the easiest way instead of you guys trying to upload them on Schoology. Yes, is just email them to me. Okay, and take a picture of it and email it to me, and I'll put that in the instructions. Okay, we got about 5 minutes left. Any questions, virtually or in person?
So the multiple choice part will start tomorrow.
Multiple choice is on Thursday. Tomorrow's just a review day for you. You can take a look at any of the AP Classroom stuff. You can take a look at any of the things posted on Schoology in the midterm section for review. right? I'll also be online if you need to come in and ask questions. Okay?
Yeah, because I saw you open 15 assignments on maybe classroom.
Yeah. And that's just review opportunity. You guys can go through you don't have to go through all of them, but you can get a sense of what those questions might look like. Okay. I don't know. Anything else? The crazy thing is after this week, we have 3 weeks left until winter break. 3 full weeks left until winter break. So.
Are we doing a group test?
We're going to do a group test next Monday. Okay, so it's going to be somewhat virtual. And the reason I'm doing that is because I know some people are, leaving for out of town for Thanksgiving. And if you're someone that's doing that and you can't join it, it's just going to be excluded from you. But yeah, we'll do a group test on Monday. So what I would say is write down the answers that you have for your multiple choice questions, right? So if you do 1 is A, 2 is B on a piece of paper, that way you can reference it, right? That way you can reference it on the group test and you know what you submitted for the group test. Cool with that? Okay. Any other questions?
Delta U is just another way of writing Delta T.
Yeah. Yep, because now it's different, right? But remember, it's like kinetic energy equals 3/2 Boltzmann constant times temperature in Kelvin. So it's not the change in energy is not equal to the change in temperature, but it's the idea that if this goes up, this has to go up, right? So it's more of that. So, yep. All right. If you have a question, feel free to stick around. Otherwise, you guys can head off. Same thing, virtual people. Make sure you hit that like button, right? Feel free to stick around if you have a question. Otherwise, have a great rest of the week. Good luck Thursday, Friday. I'll see you guys on Monday. All right.
So you're going to be absent?
I'm absent the rest of the week.
Thank you.
See ya. Brian, did I get your question answered on here? All right, I'm going to end the live stream then, unless someone has a question. Thanks for the 3 thumbs up with this. I'm going to end this now.
It's funny because then you can monetize the channel and earn money. Some of the economics and math videos that I watch, it's same teachers as you. They just translate, show their work, and they collect a bunch of subscribers.